right. Thank you very much once again for joining today's class. So this is basically a form of seminar or workshop organized by NUCSA China. My name is Clement Chumesi. I am a final year PhD mathematics student at Cardiff University in the UK. And I am also someone who already have an online class where I teach advanced data analysis in R. So most of the things that we are going to do, I already have much more advanced versions on YouTube. Okay, so I'll try not to repeat myself, especially things that I've already done on YouTube. So you can always have access to that, so that at least to make us benefit more. I think it will be useful if you try different materials or different areas. So this is just to say that on YouTube we have the R class starting as from scratch for beginners. So after this class, you can actually benefit from that as well. So this 4-day period, we cannot cover everything within the 4 days, right? So at the end of the day, we are just going to touch on the most important things you need to know, and then everything will be uploaded on YouTube as well, and you can always watch at your own pace. And so without wasting time, I'll just share my screen. Okay, so we'll actually, I would use the R Studio, but for now, I'm just trying to explain certain things for you to know. So the objectives for today is basically like 6 bullets. So the first thing is I'm going to give an introduction about the R environment, and then some IDEs. What is an IDE? I'll talk about that. I'll also talk about object, assigning object variable types, arrays, matrices, and even installing packages, and sometimes problems associated with installing packages in R. And then we'll do a bit of vector and matrix arithmetics. And then we'll look at how to set working directories and import different data formats. I think I'll talk more about the different data formats when we get there. And then we'll also talk about how attaching and detaching variables and its effect. And then finally, we'll talk about how to export data from R. So for instance, suppose you had the data, you did some data cleaning. After the data cleaning, you wanted to actually save that new data or the clean data for use later. Or even you've done any programming and you have some results, you want to be able to save them into some form of Excel or CSV file. Yeah, so we look at how you export such also. So that's what I seek to achieve for today. Now, before everything, just for those who don't know anything about programming, now I would like to talk about programming. So when we talk about programming, we shouldn't confuse programming in the context of computer scientists with programming in the context of statistics or mathematical modeling. So a computer scientist's view of programming is slightly different from our view of programming. So with our view of programming, is basically using functions to solve problems. So to solve problem, meaning that it involves data analysis. It also involves creating algorithms to solve a task and so on and so forth. But not necessarily in the context of a computer scientist. So there's a bit of difference. Now with the R, so the question is why R? There are lots of other programming languages, but one thing we have to notice is that R is the most suitable programming software when it comes to statistics. Even though Python is competing with R, in terms of data science, is actually between Python and R. But the reason why R is sometimes more robust than Python is because when you're programming in Python, there's something we call indentation. You have to be able to indent. Suppose you are creating a loop or something, you are supposed to indent your code. If you don't indent it well, you get errors just by indentation errors. But with R, there's nothing like indentation error. You don't need to indent your codes in any way. But in Python, you have to. So these are some of the reasons why R becomes another good option. And apart from that, you can actually import or work with different languages in R as well. I think you can also do the same for other languages. So basically, you can integrate more than one programming language at the same time. Okay, fine. So what is an IDE? So initially, I told you to install R, you needed to first of all install the R base. So the R base is like the default IDE. IDE represent integrated development environment. So what they do is that they help you to be able to run a programming language. So anytime you hear a language or a programming software, one thing you have to notice that there's always a platform that we use to run those languages. So the R base is the default IDE for R. So never think that R Studio, R base is the language. No, the language is the R, okay? And then the R base is the default, how do you call it, IDE to run R. However, the R Studio is a bit user-friendly compared to the R base. The R base, one thing is that for the R Studio, once you start typing, your codes or the codes can start popping up. So it's a bit user-friendly compared to the R base. So it is always recommended that you use the R Studio over the R base when you are doing the your data analysis. However, you have to note that you can only install R Studio after you've installed R base. That's one thing you have to keep in mind. However, there's also another way you can actually install R Studio directly without necessarily installing R base. I wouldn't go into these details. I've already dealt with them in my first YouTube video. So I'll always point you to those materials as well. Now, what you are seeing at the moment is called Jupyter Notebook. So clearly for the Jupyter Notebook, one thing about Jupyter Notebook is that if you can see here, let me come down a bit. Okay, so if you can see from here, I can run so far 3 languages at the same time. So I can run R, Python, and I can run a software, I mean another language called Julia. So the beauty about Jupyter Notebook is that, first of all, we can use it to run more than 30 different programming languages at the same time. So that's one of the beauty. And apart from that, you can clearly see I can make notes, I can even add links, and then I can write. It even organizes your course comparatively if you compare it to the R Studio, which I'll show you in a minute. So so very soon you will see the benefit of Jupyter Notebook. I have a whole session on YouTube specifically for using Jupyter Notebook to run R. So I would explain a bit of the R Studio for you to see the environment, the R Studio environment, but I'll switch back to the Jupyter Notebook because it's very useful when I'm teaching. It makes it easier so that you can all follow what is happening. All right. So without wasting time, I'm now going to show or share the R Studio's IDE, and then explain to you a little bit around the IDE, the R Studio IDE. Then I'll switch back to Jupyter Notebook. So keep in mind, the Jupyter Notebook is also another IDE that you can use to run R. And it is very useful, especially when you are doing a PhD or you are doing a form of maybe MPhil or something where you need to always be discussing your results with your supervisors. So you find out that with this one, anytime I run any function, the results just pops up. If it's a graph, it will pop up. We'll just do one plot. Now, I was not supposed to do data visualization today, but I'll just show you a little bit of that for now. Okay, so let me just switch to Jupyter and the R Studio. Just a minute. Okay, so I suppose most of you are using R Studio, but I would always urge you by the end of our 4-day event, you should try and switch to Jupyter Notebook. It's very useful. The beauty is that when you code in Jupyter Notebook, you can actually download the script as an R Studio script. Technically, I would say R script, but I'm just using R Studio script because I just most of you, after saving your script in R Studio, I just want you to know that that same type of script you had, you can technically download that script also in the Jupyter Notebook, and then you can also save it as an HTML file. Where with the HTML file, it meant that anyone can open with a browser and they will see all your codes, your results, and everything. At the moment in the R Studio, once you run anything, you have to manually save your results into a repository. And so meaning that at each stage, when we see your code, we'll not be able to see the results just beneath it. No, it is rather in the Jupyter Notebook that you can do that, where you have your codes there, and then just beneath your codes, the results is there. And then it can be there forever. You don't need to save it into a special folder or anything. It is there for you. So I think it's very useful, apart from the fact that you can use it to run several languages at the same time. Okay, so when you open the R Studio, this is what you see. I wouldn't talk too much about these because I've already covered them extensively in my YouTube video. So I'll just touch a bit and I'll speed a little bit up because you would be able to watch it at your own pace when I upload it on YouTube and also share to the group page. Fine. So the first thing you have to note is that this place is what we call the console. Okay. And then here is your global environment. Anytime you open or you import a data or you create a variable, whatever you create, it pops up here. At the moment, because I used to use it, I have to clear what is here. To clear the global environment, you just use rm, then list. You don't need to memorize these ones. I just want to clear that. Fine. So that is the global environment. So I just cleared it. Fine. So I suppose that's what you are seeing. Now, with this, you can actually install packages manually by just clicking install package and typing the package name. Let's say I told some people to install package mass. Then you just click that and you just click install. Okay, and it works for you. Fine. And then you can also do it by coding using a code, okay, to achieve that. Fine. But keep in mind, R can be used as a calculator. So at the moment I can do 2 plus 2 and it tells me it's 4. I can multiply. I can actually plot something. So let's say I want to generate a sequence of, let's say, a data from a normal distribution. You don't need to know these things. I just want you to see, let's say, a YouTube video on all these. So I won't talk too much about this. And let me choose a color. So let's say red. Fine. Okay. So when you plot something, this is where you see your image. To export your image, first of all, we learn how to set a working directory. So you can just click on export here, and then you can actually use copy to clipboard and just copy and paste into a Word document, but that will lose quality. So it's always good to save it actually. So you can click save as, let's say, image, okay? And then if we had set a working directory, upon clicking save, it will go straight into the working directory. Okay, so keep that in mind. Yeah. So that is one thing you have to note. So anytime you type here, this is the console. If it's just a line of code, it pops up at the same console. If it's a plot, it comes here as well. Another thing you have to notice that anything you type in the console cannot be saved. So it is not a good programming practice to be typing directly in the console. You always have to create something called a script. How do you create a script in R Studio? So you see this plus sign, this small plus sign. You just click on it, and then you click R script, the first one. Okay. Like I said, there's already a YouTube. I mean, lots of videos that I already have on these things. So we are just touching, and then you learn at your own pace after the class. Fine. So it meant to create a script. That's what we meant. So first of all, let's say I want to plot. Let me just plot something. So let's say I'm plotting 2 normal random variables, for instance. And then let's say I'm choosing a color to be blue. It's not something we want to waste time on for today. Okay, yeah, so suppose I just did a plot. Now, if I want to save the script, all you need to do is that just go to File, you click Save As, okay? You click Save As, and then so always on your desktop or anywhere you want to create a folder that you want to call maybe your R results or R folder or whatever. So you always have a single folder for all your results, okay? So you find out that when you are setting a working directory, I created a certain folder. I will expect all of you to also create the same thing on your desktop or anywhere. And always when you are saving your script, you save it into it. So I've already created a folder, and I called the folder on my desktop. I called it Nuxa China R underscore class. So if I want to save this into that folder, I just select that folder and just type how, maybe first R script. First R script. So I've saved it into that folder. Suppose I had closed R. I've closed everything. Let's say I had closed R and I've opened again. You've not lost any of your script is perfectly safe. You just have to click on File, then you click Open File, and then you go straight to your folder, and then here's the script. I just click on it and it pops up again. Okay, so keep in mind that always this is what you need to do. Always write your codes in a script, not in the console, because in the console, once you close R, you lose everything. Okay, and then yeah, so that is the only thing I'll talk about, the R Studio. So I'll end here on the R Studio and switch to Jupyter Notebook. So this is basically what you can be using for now. And the beauty about the R Studio, what I meant was, suppose I want to create a sequence, or let's say X, and then let's say I create a sequence. You see, when I start typing, it popped up. Okay, you won't get this option in Jupyter Notebook, and you won't get this kind of option in the R base. Okay, so for the R base, you should know what you are typing. For Jupyter Notebook, you should know what you are typing. But for the R Studio, once you start typing, certain things pops up for you. Okay, so let's say I'm creating a sequence of numbers from 1 to 100, and I want to separate it by 2. Okay, so here in R Studio, this is how you run your codes. You can either let it blink at the last session. As you can see, it's blinking at the last line, and you just click on run, or you highlight it. Suppose you have a big function, you can highlight the whole function and just click on run. Okay, so at the moment I can highlight all these and just run it, and then I'll get something. Okay, fine. So that's how you run. So you realize that anytime you run, it comes in the console here. However, for plot, it goes to the bottom right. So keep that in mind. All right. So it's enough for R Studio. Let's switch to Jupyter Notebook. Okay, so I'll speed up a little bit because we don't have time. The other one, what I just talked about, was just is something you can have it on the YouTube channel. Fine. So now the first thing you need to know is we are going to look at how to set a working directory. Okay. So to set a working directory, so all you need to do is that on my desktop, I've created a folder called nuxa_China. So let me see whether I can share my desktop. Okay, yeah, I think I can share my desktop. Okay, fine. So here on my desktop folder called data analysis_R. I mean, you can use any name you want. Okay, then you create that folder. So I created a folder, and inside this folder, I have lots of other folders in there because I've been doing other teachings for other groups. So I created this specific folder, nuxa_China_R. So this is the folder. Now keep in mind that if you want to import a data into R, or make sure that your data is in the folder. This folder here is what we call working directory or repository. So we are calling this the working directory. So keep in mind that the working directory is this link. So now you realize that if I type here, I can copy this whole link. So you copy it. Okay, fine. So I just want you to note that always create a folder. You can name it anyhow you want. For uniformity, you can just use the same name, or just create any name. It can be on your desktop, it can be anywhere. Okay, and then just go to that folder, copy this link, and that link is your working directory. And make sure that if you want to import data into R, your data is in the is in the folder. Always keep that in mind. Okay, so there are certain data types you are going to import, and you realize that I have all these data here. So we are going to import a SAS data. A SAS is another language. And then we are also going to import a STATA data. We're also going to import an Excel data, a CSV data, and even SPSS data. Okay, so there are people who were already programming or using SPSS, or there were people who were already using STATA or Minitab or different softwares or SAS, and now they want to switch to R. I just want you to know that all the data you already had in those softwares, you can actually import them directly into R and start working with them. So that's what I wanted you to note there. So now the working directory. So I just copied this link and then let me stop here. Sure. And now I'm going to Jupyter Notebook for now. Okay, fine. So let me create a cell down here. Fine. So when you come, all you need to do is to type set WD. So this set WD is set working directory, and then you open this quotation sign, I mean marks, and then you paste what you copied. But look at the difference. You realize that the slanting bar is pointing towards the left. Okay, what you need to do is to change it to point towards the right. That's all you need to do. That's the only stress involved. So you just change it to point towards the right. Now let me intentionally leave this one. If I run this one, I'll get an error. Okay, fine. So keep in mind. So let's make sure it points to the right, and then you are good to go. So at this stage, I've set a working directory. You can actually copy this, what I'm doing, and paste also into RStudio. Everything you do, we are doing Jupyter Notebook. You can do the same thing in RStudio. Just copy and paste, create a script. I told you it's always good to create a script. Don't type directly in the console. Always create a script so that you can always save. To save your script in RStudio, just the normal Control S can save it, just as you would save any document in a Word document or whatever. Just Control S or just go to File and click Save. That's fine. It saves it into the folder that and once you save the first script into the folder, the rest just use Control S and you should be fine. All right, now we've set a working directory. The next one is this option only helps me, and you don't need to memorize codes. Keep in mind, it's not a good programming practice to be memorizing codes. Okay, fine. So the codes, I mean, over time with experience, it will become part of you. So I ran this one to set the size of my plot and to set a specific resolution for my figures in Jupyter Notebook. You don't necessarily have to do that in RStudio, but you can also make good use of it, because with this one, it tells me to specify the kind of resolution I want, like to get a high quality image. Fine. So now the next thing is how to install packages. So in RStudio, it's easy because I showed you there's a point and click option, or you can use install.packages, and then you bring your the round circles, and then don't forget the quotation. Don't forget the quotation sign. Then the package name, you type it in there. Okay, so that is how we install a package. To install a package, you always need an internet. So keep in mind, to install a package, you always need an internet. And keep in mind that you only install a package once. So after installing this package, I don't need to install that package again. Okay, but the next time you want to use that package, you have to rather load it. Okay, now what is the meaning of packages? Now keep in mind that I think in the third session of this particular workshop, we are going to learn how to create functions. I mean complicated functions, sometimes complicated functions. So to create functions to solve some problems, people have created their own functions. Okay, so for instance, let's say I create a sequence. Let's say I create a sequence, and then let's say a sequence from, let me just say 1 to 1,000, and then I type mean. Suppose I want to find mean. Now keep in mind, you realize that I typed X and I brought a less than and a dash, I mean, or let's say a minus sign. You can equally use equal to. So this X is what we call object. Okay, so it's always good to assign your codes to an object so that you can reuse it again. Okay, so for instance, now if I want to plot X, I can just type plot X, and then it plots X for me. Okay, fine. So always it's good to create it's good to create objects, and this is what we call an object. You can use any name. So I want to create this sequence of numbers. This is actually if you want to see the sequence, it's actually a sequence of numbers from 1 to 1,000 that I just created. Fine. And then I want to use it another time. So I had to save it into something. And that thing is what we call an object. So you should be familiar with these programming terms. So when you talk about object in programming, it's nothing strange. It's about saving your results or your line of code assigning it to a certain name so that you can always call that name. And anytime you call that name, it's more like you are using that same line of code. Okay, so keep that in mind. Fine. Now, so you realize that the mean around x, the x is a vector. The mean around x, it gave me the mean. This mean is an inbuilt function. So it meant if I want to find standard deviation, I can also use SD of around the x, and it finds the standard deviation of x. Okay, I wouldn't go into all these. They are already done on the YouTube channel, but I'm just touching a little bit here. So keep in mind, you should be familiar with objects here. And I told you can always use equal to as to assign an object, or you can use the less than and this. So the less than and this is the same as equal to. But when you talk about actual equality, we use double equality means actual equality, and a single equality means assigning. Okay, so don't confuse double equal to in R with a single equal to. A single equal to is doing the same thing as this one. So I can either use less than with that or equal to. But the reason why sometimes you prefer to use the less than with this is because it looks fancy. In Python, you can use just equal to. You cannot use any other option. But in R, you can either use this one. And if those who program in Python and other softwares sees this kind of less than with that, it kind of confuses them, and it's good. Sometimes it's good to confuse people. So it's nothing strange. It's just the same thing as equal to assign an object. That's all. Fine. So like I said, to install packages, we use install.packages. Then you bring a round bracket. Then don't forget your quotation. But when you're loading the package, you can choose to ignore the quotation. Okay, fine. Now you realize that when I installed it, there was a message here, a warning message that package is not available. So there are instances you install a package and it might not be available in R. It might not be available in the version of R you are using. It doesn't mean that go and download that new version. Okay, there are always ways to go around it. Fine. So I intentionally left that error there so that you would see the kind of inconveniences you can go through when you're installing these kind of packages. Fine. So it wasn't in my version of R, but I was able to get a code online that is like a cracked kind of version that actually would help me install directly from a certain repository online. And there are also something called GitHub. Every package written, we have its version on GitHub. So you can actually download directly from GitHub. So there's a whole session that I talked about package installation and how to install using GitHub and those kind of things. But always keep in mind, to be able to install using GitHub, you always have to install a package called DEV tools or remotes. These are the packages that help us to install from GitHub. So when you're installing a package and you are struggling and you cannot find it in the version of R you are using, always keep in mind that you can always get another version of it online. You can install directly from GitHub. Okay, but always use this approach first. If it doesn't work, then you look at another alternative. But I always recommend that there are inbuilt, there are default packages that actually comes along after you install your software. So keep in mind the install.packages is used to install packages. I left this error here because I was installing this package called Haven. You will need it. I will explain when you need it. And then with this package, whenever you install a package and it's installed successfully, there's the kind of message you see. Package whatever successfully unpacked. Whenever you see such a message, you should be happy. It meant that your package has installed successfully. Like I said, you always need an internet to install a package. But after installing the package, you don't need an internet again. So keep in mind. So there are instances you are getting errors probably because you are not having an internet in the process of installing your package. So don't forget. And don't forget that you always need to bring a quotation sign when you are installing the packages. Don't forget. Fine. Now, for this, it came perfectly. I installed it perfectly. However, when so after installing, we use library around the package to load it. So it implies that anytime, if I should close Jupyter Notebook now, because I've installed this package, I don't need to install it again. So in that case, I'll use this hashtag. So we use this hashtag to comment, okay? So at the moment, if I type, let's say, Clement here, it will give me an error because Clement is not a code. It's only codes that will not give you an error, right? So since Clement is just something that I was just writing, I will just bring the hashtag, and in that case, if you run, you don't get any errors. And so keep in mind that it's good to comment, or it's good to comment your code. So here, for instance, I just wrote you can use this. Alternatively, you can use that for GitHub. Fine. So you can the hashtag is used to comment. So keep that in mind. It's the same for Python, and it's similar for most programming languages. But Julia is a bit different. It doesn't use hashtag to comment. I think a percentage sign or something. Fine. So keep that in mind. But here it installed okay. But when I was loading it, I got this error. I got this error that Erlang version cannot be unloaded. And when it happens that way, it implies that when I load it, it doesn't give me, I get this kind of error. When you get this kind of error, what you need to do is that close your R and restart it again. When you restart, don't install, just come and load it using the library and it should work. So that's what I did. So I came to the next session. When it happened, I left it so that you would see this kind of error messages. And then I just closed it, and then I opened Jupyter Notebook once again, and I just loaded the package, and it worked perfectly. So at the moment, it works perfectly fine. So here we are using 3 packages for today. You should be able to install each of them as of now. And then keep in mind that there are already YouTube videos that have extensively looked at all these. So you get access to the YouTube channel. Don't forget to subscribe anyway. Fine. So here, the foreign package here helps us to import data from different softwares or data from different statistical softwares. Don't confuse. STATA is not a programming language. SPSS is not a programming language. eViews is not a programming language. So we should understand the difference between statistical softwares, or let's say you can call it econometric softwares or statistical softwares, and programming languages. For programming languages, you realize that they are unique. They are unique, let's say, comment or languages that we use to communicate with the software. But with the other ones, it doesn't mean that they don't have some form of programming language beneath it. Keep in mind, most of the SPSS, STATA, most of them are written based on a programming language. The programming language is just beneath it, okay? I wouldn't want to go into that detail, but keep in mind that the SPSS is not a language. Even MATLAB, arguably, is a semi-language. It's not a full language. Why? Because MATLAB cannot survive on its own without C++. Okay, so and for languages, they can survive on their own. So R, I don't need Python to help me to be able to program in R. Okay, but most of the other statistical softwares, they could only write it based on a language. That's why they are not a complete language. They are just a statistical software. So let's get these things and let's go. All right. So now the next thing is how to create a vector. Or let's say we are going to do some using R as a calculator. I told you you can actually type 2 + 2. You can do any math. So you don't. So if you are using R, you don't need a calculator. Keep that in mind. Now, how do we create a vector? Okay. So here, sequence. If you use SEQ, then 3 and then 100 here. What I'm doing is that I want to create a sequence of numbers from 3 to 100, and I'm saying that it should be separated by 3. Okay, so you realize that it starts with 3, then it goes on to 6, 9, and so on. Suppose I want to start from 1. And then you specify the specific increment. Another way is that you can actually create, let's say, a sequence. So you realize that anytime I'm creating something, I consider a certain object equals that, so that I can always use that object anytime I want to call it once again. So always keep in mind, you can either use equality or you can use the less than with this sign. They are doing the same thing to assign an object. Okay, fine. So let's say I want to create a sequence of numbers from 1 to, let's say, 20, but I want to create, let's say I want to create 100 numbers. I want to create 100 numbers from between 1 to 20. So I'll use length.out equals 100. Okay, so here, so you realize that I can just type the object and run, and it gives me what I want. And you can also use print. So when you see print, it's nothing strange. It's also doing the same thing as just typing, but the print option kind of organize your output, as you can see. And if I type this X, okay, it's a bit disorganized, but the print actually makes it a bit organized. But keep in mind, you can either use the print or just type the object itself, and it should work fine. So keep in mind, you can actually create any length of numbers between any two numbers, okay? So that is another option you can make use of. So here I was asking, is the multiple of 3 I created, is it a vector? So we use s.vector and it tells me it's true, so it's a vector, fine. So here I was printing the multiples of 3. Okay, so I will start from once again, and then yeah, so here I was printing out the multiples of 3, fine. So at this stage I want you to see you can use also R to do matrix algebra. You can use R to add vectors and so on and so forth. These things are so useful. Don't think they are not useful. They are so useful because any data you have, see each column to be a vector. Any data you import, any data you created in Excel, each column is like a vector. And the entire data set is like a matrix. So if you're able to work with vectors and matrices, and you're able to subset vectors, like within a vector, let's say the multiples of, realize I'm typing multiples of 3. If it was in RStudio, it would have popped up for me. But here you should be able to type it yourself. Okay. And make sure you don't make, so for instance, if I run this, I'm getting a message that object multiple not found. So anytime you get this error message that some object is not found, it implies that you made a mistake when you were typing it, or it wasn't there at all. So here I forgot to bring L. So I forgot to bring L, and now it should be fine. So you can use something called a square bracket to subset. So meaning that, let's say I want to select the first number. Okay, so to select the first number, I just put 1 inside the square bracket, and then it will select the first number to be 3. Suppose I want to select the first five numbers, and then I use 1 to 5, and it select the first 5. Okay, so these are some of the things you can actually use. Suppose you want to take a certain number out. Suppose I want to take the last number 99 out. Okay, what I need to do is that I can use minus. Once I type, keep in mind, once you type length of a vector, once you type length of, let's say, multiples of a, okay, so once you type length, the length, let me comment this one so that I have this. Once you type length, it tells you how many elements are in that vector. Okay, keep that in mind. If it's a data or a data frame, you don't use length. We rather use dimension. We'd rather use DIM to return the number of rows and columns of that. Keep that in mind. Okay, fine. So here I'll just continue. Fine. So now suppose I want to multiply. So I've created a vector, and there's another thing I want you to note. So you realize that when I was creating a sequence of numbers, I could just use either seq to create a sequence, or sometimes I can just use this. Let's say this one with the column sign, and it creates a sequence of numbers from 1 to what? 1 to 30. But if I want to add specific intervals, then I have to use the sequence function. Keep in mind, you can actually also create, let's say you want to create a vector, another vector, which is not like necessarily a sequence that way. So suppose I'm creating a vector, let's say 5, 10, let's say 80, let's say 1, let's say 2, let's say 5. I brought a certain C in front of it. If I don't bring this C, look at what happens. Let me run this one. I get this kind of error. So keep in mind, this C, we call it concatenate sign. So this concatenate sign, what it does is that it helps you to be able to, it's used to create vectors. So the very moment you bring the concatenate sign and you type anything inside it, it will create a vector based on those entries. Okay, fine. So here, what I wanted you to know is that you have created 2 vectors, X and Y. And then I wanted you to know that you can multiply a number to each of the entries. So the very moment I type 2 times X, so let's say this is X. X is 2, 4, 6, 8, 10. When I type 2 times X, it multiplies 2 to each entry, element-wise. It multiplies 2 to each of them. As you can see, if I say 3 times Y, it multiplies 3 to each of them. So at this stage, we are just looking at some, basic introduction. And then you can actually add vectors. So I can actually add x plus y. What is the essence of this? Suppose you have a data frame and one column or one variable is age, or let's say height. And then you also have another variable called, let's say, weight. And you wanted to compute, let's say, BMI. BMI is basically your weight divided by the square of your height. So in that case, you would also be doing the same kind of thing. So suppose the x was my height, and then the y was my weight. So I can actually use this one. Maybe you can just bring a round bracket for the sake of board mass. Now, if I should run this one, it has suppose this x was like age, let's say weight, and then y was height. Suppose these are the BMI. So we use these same things we are doing for our data. Okay, so they are very useful things you need to know, that it's all about vector manipulations and so on and so forth. Okay, and then you can actually divide. You know, you cannot divide two vectors per se, but in R, once you type um, vector y divided by vector s, it divides them element wise. So it takes the first value of x and the first value of y and consider the first value of y divided by the first value of x. Then it does the second value of y divided by the second value of x and so on. When you subtract, it does the same thing. So subtraction, division, multiplication are done element wise, meaning that it depending on the position of the numbers for the two vector. I mean, so for instance, it's if you are adding, it adds the first positions, it goes to the second positions and so on and so forth. Okay, and so you don't need a loop to add numbers, you don't or vectors, you don't need a loop to multiply, even though you can use that. It's just waste of time. Okay, we'll talk about loop in our next class, which is tomorrow. Fine. So there are other options. So suppose I've created a vector called z. Now there's a function called sort that can be used to arrange your vector in ascending order. If you want to arrange it in descending order, you just add decreasing equals true and so on. And then you can actually reverse the order of your, so this one started with 5, 8, 2, 10. Now typing reverse, it brings the last one as the first and so on. So this is just to say that there are a lot of ways you can manipulate vector, and all these we are seeing, see it as they are one of your variables in your data. So you can manipulate anything you want to do. So just keep in mind, this is purely introduction. And you can also create a vector to take up strings. So anytime you are creating a string, you realize when I was creating for numbers, I just type the number. But when it's a string, one thing you have to notice that you have to bring the quotation sign. If you don't bring it, you get an error. Okay, so keep that in mind. So I'm creating a vector of 3 countries, Ghana, UK, France, and I just brought that. So you realize that the concatenate sign, the C, it's not a capital C, it's a small letter C. So don't forget, that's the concatenate sign. That is what we use to create vectors. So, and then we separate the argument, or let's say the element, with a comma. So the comma is what we use to separate each. And then it can either be a number or it can be a string. But if it's a string, don't forget to what? Bring quotation, that's all. And then you can subset it. So here, when I use the square brackets and put 1 there, I'm subsetting the first entry. If I use 1 to 2, I'm subsetting the first 2. I can subset the third one by putting 3, which is France. Yeah, so keep that in mind. So let's just continue because we don't have too much time for today. Now, the next thing is how to create matrices. So all these are going to be, they will uncover very soon by the end of our 4-day event. So now suppose you want to create this matrix. After creating this matrix, their instances may be at a point you'll be computing determinants, you'll be computing inverse of a matrix and all sort of things. Those in the non-math field will say that, why do I need to know these matrix algebra? Someone called me, the person was in, I think, one of the social sciences. The person wanted to use an algorithm called AHP algorithm. And the AHP, I've forgotten the, was it analytical hierarchical? I've forgotten the P, but the AHP is a way of it's an algorithm for making decisions, okay? And it's a way of quantifying or quantifying, let's say, relative importance to some decisions you want to make. Fine. So it's a bit of social science kind of field. However, it requires the principles of eigenvalues and eigenvectors. So so that is why I'm saying that matrices are very important. Once you can play with matrix, you can play with the data. Because I told you that every data is like a matrix because it has rows and it has columns, okay? So suppose you want to create this matrix. There are so many ways you can create it. So one way is that you first of all, so 387 is the first column, 252 is the second column, and so on. Horizontally is what we call rows, and vertical is what we call columns. So the first thing is that you can create a separate vector for each column. Okay, so here I'm creating for 387 as this one, and I'm calling it C1. Okay, I didn't use C as an object because we know that C, the small letter C, has a unique function in R. So you wouldn't want to use a unique function as an object name. So you know mean represents a function. So you wouldn't want to type mean equals something. You would want to maybe use mean underscore something. And always keep in mind that when you assign your object, so for instance, let's say, don't do something like this. Let's say mean value equals, let's say 3. If you do this, you get an error. Okay, you can either use a dot or you can use an underscore if indeed you want to do something like that. Okay, and then you can always print back what you wanted. Fine. So here you realize that if I type mean, it prints the 3 because I have assigned 3 to represent the mean. I mean, the mean value has been the object that I've used to represent the 3 at the moment. Fine. So to create a matrix, you can create a separate vector for each of the columns. And when you are done, you use a function called cbind. Then in brackets, the first column, the second column, the third column. And when you do that, it creates the matrix you want. Another alternative is that you realize that this is the first column. So I type the first column here. This is the second column. I also typed the next column. And this is the third column of the matrix. And I brought it. Okay. And then if you check here, I said it's 3 by 3 matrix. So I brought n rows equals 3, n col equals 3. And I said by row equals false because I entered it by rather picking the first column, then the next column, then the next column. So I said by row equals false. If I say by row equals true, then I'm rather saying that the first 3 correspond to the first row. That wasn't what I did. So you realize that here I copied the first column is the first 3, then the next column is the next 3, and so on. Fine. So this is also another way of creating a vector, a matrix just based on the columns. Okay. So you can also do the same for the rows. So here I can also create a separate columns for each row and then rather bind the rows. So you use something called rbind. Okay. And then you can also use the same thing where you bring the first row and then the next row and then the next row and rather say by row equals true. So that is also another alternative. So there are so many ways. Just stick to one approach that is convenient to you. Fine, let's move on. So if you remember, I told you that a single equality actually means assigning an object. So now we've created, let's say, matrix called A1 and A2. A1 and A2 are literally the same thing. And then this one is also the same thing as the A1 and A2. What I did was that we're just using different approach to create a matrix. Fine. Now, the very moment I use double equal to, what the double equal to is saying is that for the first entry of matrix A1, is it the same thing as the first entry of matrix A4? So that's why you realize that it's telling me true. So if it's not the same, it will tell me it's false. Okay. So so that's what we meant. Double equal to really means you are asking whether something is equal to something. But when you use a single equal to, it doesn't represent equality. It rather represents assigning an object. And then I told you a single equality is the same thing as using a less than and a minus sign. Okay. So these are just, and that's why we call it a language. So these are things you should be familiar with it so that you will not be getting unnecessary errors. Now we already know matrix A. Suppose I want to find a determinant. I just need to write DET. So I don't need to use a calculator. Suppose you have, let's say, a 10 by 10 matrix or even a 100 by 100 matrix. You cannot create it in a calculator, isn't it? But I can easily create it in R. And then if I want to find a determinant, I just type DET around it and that's it. Okay, fine. Now, another thing I want you to note is that suppose I want to multiply two vectors. In R, if I use the asterisk sign, it's represent multiplication. But when you're suppose A1 is a matrix and I'm using another A, or let me say I'm using A4 or A4. So suppose I want to multiply these two matrices. Don't use the single asterisk. Bring the percentage sign before and after that. That is what represents matrix multiplication. If you don't do that, it will multiply your matrix element wise. You know, matrix multiplication is a little bit complicated than just multiplying the first entry of the matrix A, and the first entry, and so on and so forth. So if you really want to do actual matrix multiplication, don't forget to bring the percentage sign and before and after the multiplication sign in R. The asterisk is the normal multiplication sign, but for matrix multiplication, don't forget to bring the percentage sign. Let's just go on quickly. So if you want to find inverse in R, the function for the inverse is called solve. So once you type solve around any matrix, then it gives you the inverse of the matrix. So that's the inverse of the matrix. And you can get all, you can have a very large matrix, like 100 by 100, 1000 by 1000 matrix, and the software should be able to do these things for you easily. So don't forget that. If you want to find eigenvalues of, let's say, of matrix A1, all you need to do eigenvalues and eigenvectors. I don't suppose you know it. So don't assume that you should know everything here. This one is just exposing you to something for the first class. So once I type eigen around the matrix, it gives me the first three things you are seeing are what we call eigenvalues. If I have a 3 by 3 matrix, you are going to get 3 different eigenvalues. If I have a 5 by 5 square matrix, you are going to get 5 eigenvalues. So this is what we call eigenvalues. Later on, you wouldn't understand eigenvalues if you are not in maths, but I don't want you to understand. I just want you to know the kind of things R can give. And these are what you call the eigenvectors. You need, if you are doing the AHP, for instance, a social science kind of algorithm for decision making. However, it makes use of eigenvalues as well. So that's it. So, and then you realize that when you run it, it gave us 2 different outputs, and it brought a dollar sign, and then it brought values. What it implies is that anytime I copy that dollar sign values and I rather put it in front of it, it will only extract that version, that part for me. So we use this dollar sign for extracting as well. So keep that in mind. So here you realize that the original eigenvalues print out values and vectors. So when I copied this and put it in front of the actual function that gave rise to that, it only extracted the vectors. Okay, so keep that in mind that we also use the dollar sign for extraction, and we can also use square brackets also for extraction. All right, so we have very limited time, so I'll just speed up a little bit. So now the next thing is how to import data. We are going to import different data sets, and the beauty is that by the end of today, you should be able to import any data you were working with. It could be you were already into SPSS, you were already into STATA, you were already into eViews. You did some analysis in STATA. Every analysis you did in any software, you can do everything in R. So keep that in mind. And there are a lot of things you can do in R that you cannot do in other softwares. There was this PhD student also in the UK who was trying to do a certain econometric test. And the test was basically called nonlinear Granger causality test. Would you believe that eViews can only do, and STATA can only do a linear Granger causality? It couldn't do the nonlinear, but in R, there are a lot of people who keep writing packages to be able to solve these kind of problems for you. I've been able to create a function that can do your summary statistics for you, and I wouldn't go into the complications for today. It's already on YouTube anyway, but I'll touch on it maybe tomorrow. Fine. So here, to import the data, the first thing is to set your working directory. We've learned how to set a working directory from the beginning, right? So it implies there was a data that I called meta rates. All the things I'm using, you have access to them so that you can practice on your own. You can do these things directly in your R Studio, okay? So I'm doing it in Jupyter Notebook because it's easy to teach with it. But you should do the same thing in R Studio. I'll actually download. So when I'm done, I can actually click File and go to Download As. This is what I meant by I can actually download as R. When I download as R, is the normal script you have created using R Studio. If I download as HTML file, I will show you that for the HTML file, what it implies is that you'll be able to see all the codes and the graphs, everything, the same way as you are seeing now, with that, but it cannot be edited. So suppose you are a PhD student and you are doing a lot of analysis, you have to communicate with your supervisors. It could even be an MPhil or a master's study, okay? To communicate with your supervisors, do you think it's always necessary to create it in, let's say, RStudio or a certain software, and then copy and paste your results into a Word document, I see that as waste of time. You can actually do everything in your in the Jupyter Notebook and rather send the HTML file to your supervisor. Your supervisor will click on that and will be able to see your course and your results at the same time. Okay, so that's the beauty about that. Fine. So the data was called meta rate, and because the data, I saved it as a CSV file. For those who don't know how to save a CSV, it's straightforward. So, for instance, when you open an Excel, because of time, I wouldn't want to, maybe you give me a little, maybe 5 minutes extra, so that I wrap up because there was a bit delay. Fine. So when you open Excel, let me just demonstrate to make life easier, since most of you will be making use of that. So let me quickly open Excel, and then I'll share. You won't see it now. I'll share the screen very shortly. Yeah, so I'm opening Excel at the moment. Just a minute. We are almost done. We are almost done with today's session. Once we learn how to import all the other, yeah. So I've opened Excel now. Okay. Has it opened? Yeah. So suppose you had a data you create. Anytime you're creating data, make sure the first rows represent your variable names. Okay. Let's say height, whatever. So, and suppose you have a whole Excel data. I know everyone can create data in Excel. So to save it as CSV, you click on File, then you click on Save As. The normal way you would have saved. Then you click on your browse. Fine. Those of you who are using other operating systems, you do the same thing. The only thing is that they save as type. Now, keep in mind types of, even 4 different types of CSV here. This is what I want you to use. CSV comma delimited. That is the CSV you should use. So not the Macintosh or MS-DOS. It's actually comma delimited. So don't forget. So once you click on this one and now click on save, it is like the same Excel. However, the extension is now CSV. Okay, so that's how simple to create a CSV file. Let me now share the Jupyter Notebook and wrap up fast. Okay, so what am I sharing? Not this one. So I'll need about 10 and maybe 5 minutes to wrap up. Okay, this one. Oh, why am I not seeing? Sorry for the inconveniences. I'm trying to open. Okay, this one. Okay, fine. Yeah, so there was a data created in Excel, and I just changed the extension to CSV, comma delimited. So, and keep in mind that this data has already been put in the folder that I told you. So since it's a CSV, just bring the extension .csv. Always, you need to bring the extension. If it's a STATA data, you should know the extension for STATA is DTA. If it is Excel, the extension for Excel is XLX. Is it XLXS? I mean, we will see that shortly. But it's so easy to import. So it is only CSV data and text files that you don't need a package to import. But if I want to import a foreign data, so R sees Excel as a foreign data, R sees STATA data as a foreign data, it sees SAS data as a foreign data, it even sees eViews and Minitab, any other software as a foreign data, but it recognizes CSV as an inbuilt kind of data that you can easily import without using a package. So it implies that just the data name bring .csv, then you can choose to ignore the file equals. Okay, once you run this one, it actually import the data. The head of this, I set n equals 6. If I don't bring n equals 6, it will by default print out the first 6. I'm just bringing n equals so that you can always play around with it. Set it to 10 or anything you want. Setting it to 10 means you want to see the first 10 rows of your data. Okay, that is just to show that you've imported the data. That is, so it's not like it's something which is a must, you must do. No, it's just for you to know your data has been imported successfully. That's fine. If I use tail with the n equals 6 means I want to see the last 6 rows of the data. Fine. So this is how easy to import a CSV file. Just use read.csv, and then don't forget your quotation sign. And then the data that you saved in your repository, just bring the .csv. That is it, and you've imported. Don't forget you need to set the working directory first. Now let's go straight. So the next thing is, suppose you want to import Excel. I won't recommend you to import Excel directly because you can easily convert it to CSV by changing the extension and importing without a package. Suppose you don't want to do that, you want to go the compose and you want to import Excel directly. You use this package called read XL. Okay, so there was another data I put in Excel, and I put in the repository or the working directory or the folder. I called it transform underscore data. So I just have to bring the .xlsx, and that is the extension. And that helps. Without bringing the extension, we will not know what data you're importing. So I can technically have the same transform underscore data and have a CSV version of it and have an Excel version of it. The only difference is that once I bring the dot extension, it gives me the type of data I was trying to call. All right. So the read underscore Excel, before then you need to load this package. Okay. And since you've seen library of this package, it implies that I've already installed the package using the install.packages. And like I said, if I should close R at the moment and then open R again, I don't need to use the install.packages anymore. I'll rather want to bring a bullet, I mean the hashtag to bullet it or to comment it so that I don't need to run it again. Don't install a program you've already installed. It will just mess up the previous one. So keep that in mind. Once you are using R and then there was a package that you've already installed, you only need to bring the library. If you don't bring the library and then you try to install, it will tell you that read underscore Excel cannot be found. The reason is because there's a package you need to unload or you need to load in order to be able to use that function read underscore Excel. Okay, because someone created it and then the person wrapped it up in a package. So don't forget that. So this is how easy to import an Excel directly, but it's always advisable to convert it to CSV first. Anyway, but you can import it. If it is SPSS data, suppose you've been using SPSS all this while, you can actually start. Oh, sorry, sorry for there was just a sound, whatever, alarm, fine. So to import an SPSS data, keep in mind that these data sets, to import SPSS data or STATA data, you don't necessarily have to have STATA. So suppose you met a certain group of people and they wanted you to do some analysis for them, or they consulted you, or your supervisor has a data in SAS. SAS is another language, okay? And then your supervisor wanted you to do some analysis based on the SAS data or based on the SPSS data, but you don't want to use SPSS to run any of your analysis. R is the best, and you find out why R is the best for statistical analysis, okay? For data visualization, everything is just the best. So in that case, you can actually import the SPSS data, even whether you have SPSS installed on your laptop or not, okay? If you don't even have STATA, if you don't have SAS on your laptop, you can still import a data which is a SAS data. So keep that in mind. Fine. So at the moment, the data, the SPSS data was called combined underscore SPSS. I just name it that way. And the extension for SPSS is .sav. So you realize that I brought the extension, and to read, I use read.spss. When I was importing CSV, it was read.csv. When I was importing Excel, it was read underscore, okay, this one was underscore Excel because the person who wrote the package made the function to be underscore Excel. So you don't change it, okay, because that's what the person who wrote it actually called it. Fine. And then you just bring these things there. So with this line of code, you should be able to import any SPSS data into R. Okay, and to know that so I just use the head to view the first 6 rows. You can bring the N. And then so now it implies I've imported the SPSS data, and I can do any analysis I want to do with it. okay, just as I had imported an Excel or like I had imported a CSV file. Okay, so STATA, the extension for STATA is .gta. So we use read.dta, and this one was another STATA data. You have access to all these data sets, and you should be able to import them and play around with them. Fine. So this helps me to import the STATA data, even without having STATA on my computer. And the next one was to import SAS. One way is that those who are using SAS can actually use this line of code to convert the SAS data to CSV before importing using the normal approach we use to import CSV. However, that is a long process. You can also import SAS by just using read underscore SAS, and then the data name was IMM10. That was the data name, and the dot. This was the SAS is the SAS extension. We have different extension for SAS. You just have to specify extension, and you would be able to import the data. So at the moment, I've also been able to import a SAS data. And then so once you've imported the data, you can type summary around the data, and it kind of summarizes. So at the moment, I'm trying to do a little stat analysis on the SAS data. So I just type summary. It's an inbuilt function. Keep in mind that anything you realize anytime we write a function, we bring a square bracket. A round bracket. That round bracket, anything inside the round bracket, we call it what? Argument. Okay. So keep in mind that every function, you have to open a bracket and specify some argument. Okay. But the argument you specify, you should make sure that the argument is in line with the person who wrote it. However, you can also create your own function and specify your argument anyhow you want. Okay. Now here, this is something I want you to note. We've imported this data. You realize that there's a variable called sex and there's a variable called race. That when the person was coding it, the person coded sex as 1, 2. At the moment, R cannot tell whether this variable sex is categorical. It's categorical. Okay. Categorical. It cannot tell. You have to be able to decide. So keep in mind that the software, you have to control the software. It's like driving a car. You have to control the car. So the software, you have to tell the software what you want. So all these variables, I should be able to tell the software that sex, race, region, urban, they are all categorical. At the moment, if you type summary, it computes the mean, the first quarter median for all of them, even including those that are categorical. Okay, because at the moment the software does not see it as categorical. It sees as just some numbers. Okay, fine. So at the moment, suppose I have imported the SAS data. Okay, I've imported it, and then I just run this one. I wouldn't recommend you to use this function to summarize your data. Like I told you, I have created a very sophisticated, complicated data that we'll learn tomorrow. It's already on YouTube, but I'll just explain a bit for you to know how. So it's a function that will pick your data set and then do summary analysis. It will first of all ask whether your data is categorical or numerical. If it is categorical, it will compute percentages and plot some pie charts. If the categories are, let's say, 20, it will choose different colors for each of your categories. If it is a numeric variable, it will compute the means, kurtosis, skewness, a lot of information, and then it will plot histogram for you as well. I've created that function in such a way that it picks your data, any data, and it should be able to do all these things for you without wasting any time. By the end of by watching all the YouTube videos, you should be able to do something similar. And then I already have a YouTube channel, like I said, and I also have another online class that I've been doing, and I manage it on a software called Piazza. So on the Piazza, you have access to all the scripts that I've been using in the YouTube. So if you want to be able to have access to all the data, whatever I'm using on the YouTube, you might have to send me your email address. Then I'll send you a link for you to enroll. You don't pay anything for it. The whole thing is that if you're not enrolled, you cannot be able to download all those files for free. Okay, so it's something you can always take advantage of. Fine. So here now I've imported the data. Keep in mind each column is like a variable. So let's say sex, the variable sex. At the moment, I'm trying to print it. When I print it, it says sex object not found. You get these kind of errors. So I want you to keep in mind. Now, keep in mind that after importing data, if I want the data, I called it, you realize that I imported the data and I gave any name I want to it in R. So I gave this object name. So anytime I use this object name, it implies it's the data that I've imported. I don't necessarily have to use the same name that was in the folder or the repository. I don't necessarily have to use the same name for it. Okay. Now, if I want to extract the variable 6, I rather have to bring the data name and bring a dollar sign and then rather run. If you don't do that, it cannot extract. Okay. So that is what we mean by the moment, if you type any variable, let's say race, it will not recognize race. But the very moment you bring the data name with a dollar sign, then it will extract that variable called race. Okay, so keep that in mind. Fine. So that is what I was trying to explain here. And you realize that sex was coded as 1 and 2. So if I want to check the categories of sex, so suppose I type, let's say, we have a function called levels. If I type levels of this, it will tell me now, because levels is used to check how many categories are there in the categorical variable. We coded sex as 1 and 2s. The software currently cannot see it as what? A categorical. So I use something called as.factor around it. So the very moment I type as.factor around the variable sex, what it's saying is that it should treat it as a factor. Okay, so as.factor is to say treat it as a factor. If I say as.numeric, it means treat it as a numeric. If I say is.factor, so if I say is.factor, factor rather means that is the variable I'm considering, is it a factor? So the very moment I type is.factor and I run this one, it says false because it's seeing it as a set of numbers. Fine. So you should be able to assign dummy codes, or you should be able to assign names to your categories. So now to create an actual variable called sex and to assign one to, let's say, male, because you realize that 1 represents male, 2 represents female, all you need to do is this line of code. So you use the data, you bring dollar, this variable called sex. The same thing is what you put here. Then the levels. So that's why you always need to check levels. You always have to bring levels in brackets. Then as.factor, especially for those that were coded as numerics, okay, even though they are categorical, you have to bring as.factor around it before you be able to see the unique categories. So those unique categories are what you call the levels. And you realize that I have to bring a concatenate sign because I'm creating a vector. And then I have to also bring another concatenate sign because I'm creating a vector for the names. Okay, so the names here is what we call the label. So here the 1 represents female. So the one represents male. So that's why male is the first, and the 2 represent female. Once you do that, now if I print this one, it has prints the males and females. Okay, and it actually goes into the data as well. So now if I should actually type, let's say, head of the SAS, almost done, the SAS data, you realize head of yeah, yesterday I had this, we'll come back to it. So it will convert, let me just run this again. In that case, I'll just import. So let me just run. Okay, so you realize that now it has changed the sex to females and males and so on. Okay, and now I can use table to look at the categories of males and females, and then I can print the race to realize that they coded it as a dummy. You can also assign the code where so here I use the as.factor to know the unique categories, and then I can now know the specific categories, and then I can assign the unique names to the categories using the same code. So this is a way of assigning names to any categorical variable in R. So keep in mind that this is what you use to assign. If you code anything with dummy codes, this is what you need to use to assign names to it. That's all. Fine. So that is all I needed to show. So here you realize that if I try to call, let's say, if I try to print sex, if I try to print sex, it will give me an error that it cannot be found because if you remember, yeah, sex cannot be found. But now the very moment I use attach data, if I type attach in bracket the data name, what you are telling R to do is that it should recognize each of your variables. So in that case, I don't need to bring a dollar, I don't need to bring the data name and a dollar sign anymore. So at the moment you realize that I just type print six and it print it because I've attached. So this is what I meant by attaching a data. So if you attach a data, it automatically recognizes all your variables without necessarily having to bring what a dollar sign. But what is the disadvantage of that? The disadvantage of that is, suppose you have you can import more than 10 data sets at the same time. So you realize that at the moment I've imported 4 different or even 5 different data sets into R, and I can do my analysis, all of them in parallel, isn't it? Fine. Now suppose there's another data that has a variable called sex. The very moment I've attached, anytime I'm calling sex, let's say the sex I'm calling sex data from another different data set, but it will automatically be using a wrong variable from this one because it only sees sex to correspond to the data from the SAS. So that's why if we're importing a data set and the data set has some variables that are very similar, don't attach. If you attach, you'll be creating that confusion because it will not know which one it should consider. So be careful. So that's why I always would advise you to be using a dollar sign. You can use attach. That is if and only if you are working with only a single data set. Okay, if it's just a single data set, or you are using different data sets, but the variable names are different, you can use the attach, and that will save you from using the dollar sign. If you want to detach, you can actually use detach function, and then it should detach. Now you realize after detaching, if I print sex, it says sex cannot be found because I have now told R to remove or to not to recognize them. Okay, fine. So you realize that I've been able to add converted the race from 1 to 4. I've used the actual names, and sex to have used the actual names. So suppose this is a new data set. I'm done actually. So this is a data that we've actually, so suppose we clean this data and I want to actually export this data I've created directly into my repository. All you need to do is that you just use write.csv, then the data. So the data was SAS underscore data because it's a SAS underscore data that I've tried to do some transformation. Okay, so all I need to do is that let me just put any name that I want to give to what I want. So suppose in the folder I want to call the new data as SAS underscore data underscore updated. I just have to type that and bring.csv. When you write this one, it will save this data and give the name and give this name to it and save it as a CSV and take it back into your repository. Okay, so that is the beauty about always setting a repository or your working directory. So this is technically the end of the class. So what we just did, a quick summary of what we just did was that we've learned basically what IDs are used for. We've learned that you can actually program R in RBase, RStudio, and Jupyter Notebook. But the Jupyter Notebook technically can be used to program Python, can be used to program any programming language. So at the moment, I use Jupyter Notebook to run 3 different programming languages at the same time. Fine. So, and we've learned about objects, that objects are certain names that we just assign to some line of code, especially if you want to call back that line of code. You don't have to always create that same line of code anytime you want to call it. So once I give it a simple name, that name is the object. I can now be calling that object, and then I don't need to be creating that line of code anymore. Fine. And we've learned that you can actually use R as a calculator. You can even use it for matrix algebra. You can use it for vector algebra. You can use it for finding eigenvalues, eigenvectors, determinants, and all sort of things. And another take-home message is that every data frame is like a matrix. Every data is like a matrix. So you can actually subset the first columns. You can subset the first 3 columns. You can even obtain subset of your data. You can do anything with it. So with the vector, we're using a square bracket, okay, and we just put the particular set of let's say entries that we want to extract. If it is a data frame, we'll use a square bracket, the same square bracket, but we'll bring a comma in between the square brackets, where the first part will represent rows and the second part will represent columns. In my YouTube videos, I've already done these things. I don't want to go much into that. So I'll just send you the videos, the YouTube videos as well. And you can actually watch most of these things, because I try to approach my first class different from the first class uploaded on YouTube, so that at least you benefit, you learn something new from here, and you also learn something new from the YouTube as well. And then we've learned that you can actually import any data structure or any data from any software into R. So if you were initially an SPSS expert and you want to switch to R, you can technically import your SPSS data directly into R, but you need a package. And we've also learned that you only install a package once, and we use install.packages around, and then you bring always the run bracket is what specifies the argument. So you bring the run bracket, and if you're installing a package, you need an internet, and you always have to bring a quotation sign, if you remember, a quotation. But when I'm loading, I don't necessarily have to bring a quotation. I mean, so you realize here, when I was loading, I intentionally brought brackets at the quotation, but I didn't bring the quotation for this one. I just wanted you to know that it works even without the quotation. But when you're installing, you need to have the quotation. There are instances you install a package and it will tell you that the package successfully unpacked. If it says successfully unpacked, it's usually a good thing to show that your package has indeed unpacked. But there are instances you load it and you are still getting some error that it maybe rlang cannot be unloaded. When you get such error, just restart your R, just close it and start it again, and don't do the installation, just go to the loading and it should work in most of the time. If the package, and there are instances the package cannot be found in the R CRAN, meaning that it's not in R. In such instances, you can download it directly from GitHub. To download directly from GitHub, you need to make use of a package called DV tools, DVE tools, or remotes. That is what we use. And I've already covered that extensively in my YouTube classes as well. So I'll end here. Don't forget, everything will be uploaded on YouTube. It will also be sent on the page. And I'll be very glad if you can stream it and using the YouTube the YouTube link. And don't forget to subscribe. And there are a lot of things already on the YouTube which you should learn. So all the things we are doing, I've practically done the same thing on YouTube. But this time around, for this workshop, I'm going to approach it from different point of view. So there are things you will not have seen it on my YouTube already. So I try and approach it from different point of view so that at least it will be much more useful than repeating the same thing over again. All right. So I'll end here and thank you very much. And I'll see you tomorrow the same time. Thank you very much.